Hard problem? What hard problem? Give me more money and we'll have conscious AI. I'm a little bit annoyed about this because I think the science is clearly on our side. All the money, political clout is on their side.
I think once AI starts acting autonomously in the world, we should seriously discuss its personhood. AI is not a deterministic program. It's a probabilistic entity. And even developers who are developing those AI systems, they're not 100% sure how AI will behave in certain circumstances. Can AI become conscious? I don't know. It might. What it would take to create conscious AI? Is it quantum computers? Do we need organic tissue for that? This speculation worth discussing, which I did in this conversation with Stuart Hameroff. Stuart, together with famous physicist and Nobel Prize winner Roger Penrose, proposed a theory of consciousness called orchestrated objective reduction. So they claim that consciousness occurs due to quantum effects in human brain. Today, in this conversation, I'll discuss with Stuart what it might take to create conscious AI. The main scientific argument against your theory is that the coherence happens too fast, and inside human decoherence, and that's why it's impossible to observe that effect inside the real human brain.
Any biology, even a worm or a paramecium.
What proof you give to the scientific community that it's still your theory still has potential?
Okay, first let's go back to why people say the decoherence is too fast. And there's a guy named Max Tegmark. He's a famous physicist. I don't know where he is now. I think MIT. Well, he's a lot younger than Roger. Let's put it that way. He wrote this paper in 2000, which I think he was trying to shoot down Penrose and me. Mainly Penrose.
Penrose, such a famous physicist, right?
Exactly.
Like you want to target.
Exactly, kind of like in the Wild West with the top gunslinger, and then some punk comes out from behind a bush and shoots the guy in the back because he wants to say, "I killed Wyatt Earp." That's what Tegmark tried. He tried to take out Roger Penrose with a really cheap shot. I remember this paper came out. He calculated the decoherence time. He didn't do any measurements. He calculated from a formula that he made up the decoherence time of a microtubule as 10 to the minus 13 seconds. So that, which would be way too, because, we were thinking, well, it has to be, more like, at that time, 25 milliseconds for 40 hertz. Although now we say megahertz would be fine, megahertz and gigahertz. But what he did, so he published this, and he didn't ask us any, he just published, and he came up with this formula, and it predicted 10 to the minus 13 seconds. And it came out in Phys Revue, or a pretty good journal. And everybody said, well, you guys were just disproved, nice try, but forget about it. It's way too fast. But we looked at his formula. First of all, I showed the paper to Roger, and he looked at it. He said, well, according to this, quantum effects are impossible, so this is ridiculous. But I said, should we write a response? He goes, no, why bother? However, I went to two other friends, and physicists, and they looked at it, and they said, well, he made a big mistake here. And so he has this formula for the decoherence. Time t equals... and then an equation, I forget, but in the denominator of the equation was a term for the superposition separation distance. So in superposition, a particle is separated from itself. And we actually looked at it three ways: the level of the protein, the level of the atom nuclei, the level of the nucleons and protons. And the dominant effect was if every atom in like a tubulin was separated from itself by its atomic nucleus. So imagine, you have all these carbon atoms, and you go inside and you have a carbon atom, and then you shrink down even more to just the nucleus, which is in femtometers, 10 to the minus 15th meters. We calculated the superposition of an atomic nucleus separated from itself by its diameter, or radius actually, which was femtometers, 10 to the minus 15th meters. That's the separation distance. Now, that's important because in Tegmark's formula, he came up with a superposition separation distance that he made up, I don't know where he got it, of a soliton propagating along a microtubule, separated from itself by 24 nanometers, three tubulin lengths. So his separation distance in the denominator was 24 nanometers, which is 10 to the minus 8th. Our number that in our theory was 10 to the minus 15th. So that's 7 orders of magnitude in the decoherence time. So when we applied that to his result of 10 to the minus 13 seconds, we got 10 to the minus 6 seconds. And we also found two other mistakes that brought it down to 10 to the minus 4. But just taking 10 to the minus 6 seconds that's enough, because now we just say 10 megahertz, so 10 to the minus 7. So that's 10 times more than we need. Even if his formula was right, correcting for that, the superposition that we use instead of what he made up and pulled out of his butt, you get a decoherence time of 10 to the minus 6, which is long enough.
Didn't other mathematicians and physicists look at his work and see that mistake? I mean, if something like really coming out that attacks Roger Penrose, I guess other physicists, they would look at it.
They wanted us to be wrong. They really, most people. I mean, everybody loves Roger. You can't help but loving him. He's just a wonderful person all around. But his ideas are controversial. They go against the mainstream in physics and cosmology. The Big Bang and quantum mechanics, relativity, space-time, and he kind of takes unpopular views despite being popular. I'm kind of like loudmouth and arrogant and brash and tell them to F off, and so people don't like me that much. But I'm kind of like I'm kind of the bad cop, and he's the good cop. It was an attack, and everybody assumed they were wrong, and we still. So anyway, I didn't finish the story. So two other physicist friends of mine, Scott Hagen and Jack Jasinski, took Tegmark's formula, changed that one term from 10 to the minus 8 to 10 to the minus 15th. For the distance separation, and published in the same journal a year later. The number was actually 10 to the minus 6 or 10 to the minus 4th, but nobody cared. Everybody still cites Tegmark because he shot down Penrose without realizing that he was completely wrong. And I asked him several times to retract the paper or make it public, and he refuses. So he scored a lot of points. He got famous for being the guy who showed Penrose was wrong, even though he was wrong and Penrose was right all along. There's a lot of momentum on the side of AI and computation. And like I said, now I think AI is funding in a lot of labs, and NYU School of Machine Consciousness, which is, I keep asking, well, how do you get...
Do you know what they're trying to achieve with like machine consciousness? What is it like they're researching if machine can regain consciousness, or what exactly do they research?
I have no idea. And I tell you, Dave Chalmers has been a good friend of mine for 30 years. And I called him out on this because... he's famous for the hard problem, how there's something special. And now it's like, hard problem? What hard problem? Give me more money and we'll have conscious AI. I'm a little bit annoyed about this because I think the science is clearly on our side. All the money and political clout is on their side, but that doesn't bother me.
If you had lots of money, like any budget you need, would that allow you to perform like larger scale experiments to test your theory? Is it not the money issue? There's some other issues.
It's not the money.
It's been around for 30 years, right? It's really like interesting theory, like interesting hypothesis. It's outside of box thinking. From the perspective of just like some random idiot, I'm just trying to understand, within those 30 years, have them been like conducted experiments that show that, like signal that, okay, this theory has like a huge potential? Because 30 years is enough time.
Yeah, anesthesia acts by quantum effects on microtubules. That's pretty clear, although the people in anesthesia don't want to admit it. They used to say it's the GABA receptors. It can't be GABA. Now it's like, well, it's emergent. There's no one molecule, which is complete horseshit, because that's the one thing we know about anesthesia is the Meyer-Overton correlation, that the potency of anesthetics correlate with their solubility in a particular nonpolar environment. So then there's all these other cartoon neuron theories. So I claim that our theory has more explanatory power. We can explain way more about what's going on in the brain, including binding, unitary coherence, the self, memory, way more explanatory power, way more biological connection, because these other theories, the cartoon neuron theories, are just looking at cartoon neurons. They may as well just be, drawing them on a paper. There's no difference between that and how they perceive it, how they see it in the brain, and experimental results. We have experimental results from the anesthesia that's pretty convincing if you actually look at it, which they won't. We have experimental results that are just coming out now that megahertz, which can only come from microtubules from the brain, goes away with anesthesia. We have more results favoring us, but we're outnumbered. There's basically, me and Roger and a dozen of our friends. Well, actually, more and more people are coming around to it, but we're still way outnumbered. And AI, with the success of LLMs, which is very impressive, I have to admit, they're just pouring more and more money into convincing everybody that AI is the right way and will be conscious. And I don't even think AGI will be conscious. I retired from anesthesia, and I was just going to kind of mess around with consciousness, but I wound up working in astrobiology, looking for the origin of life with my friend Dante Loretta. Let me switch gears to evolution a little bit and the origin of life, and how does consciousness fit in life, right? Now, most people would say that consciousness emerged from complexity, information processing in the brain, maybe fairly recently with tools or language or something like that. You need a brain. I don't think you need a brain. And in fact, I think Roger's mechanism of objective reduction, which gives you experience, can actually happen without life. It can happen in a molecule, it can happen in space.
Should it be some organic molecule, or it could happen like in a rock? Or remember the Stanislav Lem novel, Solaris, and that ocean was conscious, or it could happen like some non-organic.
And some people think the universe is conscious, and panpsychists think everything's conscious, and you can have these quantum collapses in anything, and it doesn't have to be organic, and it's going to happen in the coffee cup over here, it's going to happen in the air. But when that happens, it's random. The feeling that might go along with it is random. It could feel good, could feel bad, could be neutral. And it's just going to happen and then go away. There's no memory. There's no connection to anything else. It's isolated. This sounds weird to say that these little events are happening all around us constantly. It's kind of like protoconscious noise. We call it protoconscious because it's isolated, disconnected.
If it can happen around us randomly, why it can't happen in AI models, in GPUs?
Good question. And the answer is that you need... So we call these protoconscious, and they're disconnected, and they come and they go, and they don't know about the other guys, and we don't know about them, and they don't know about us. They're just kind of having these protoconscious moments. So how do they turn into us? Well, if you go back to the origin of life, which is now what I'm now studying, nobody knows, actually. My contribution is that I realized that Roger's objective reduction could happen anywhere to give these protoconscious moments. So most people would say life started in the primordial soup, which was, and that these molecules, these aromatic rings, the same aromatic rings I was talking about, like the benzene with the 3 extra electrons, or the indoles with the 6 and the 5, or more complex ones, buckyballs and nanotubes, and all these are all organic molecules that can all have these quantum optical effects. They are made by stars. The sky, the universe is full of aromatic rings floating around. And they're very stable. They're made by stars, and they just kind of float around. And in fact, the interstellar dust, have you ever seen those pictures of the interstellar dust green? It's because they're fluorescing green from UV light from stars that cause the aromatic rings to fluoresce green, to get excited and give off green light. And the same aromatic rings in our brains do the same thing, green light. They could be entangled. They could be even communicating with each other. We don't know. But they're the same aromatic rings that we have on Earth. In fact, all of our aromatic rings and all of our life precursors apparently came from space, from meteorites and so forth. Anyway, I wrote this paper that talked about Penrose's objective reduction, these protoconscious moments. And then I said, imagine we're in the primordial soup, and we have these aromatic molecules in my cells. Operin Haldane, Operin was a Russian, I think, and he had this idea for the origin of life in these my cells, where the aromatic rings stick together and the polar tails stick out, like soap bubbles, or like little cells, actually, which we found, or Dante's found in the samples from the asteroid. In the paper, I said, well, the organic rings get together, they couple by van der Waals forces, they start oscillating, and terahertz, and eventually they'll reach threshold and have a conscious moment by Penrose OR. But now they're kind of organized, so rather than just being random, these molecules, if occasionally they have a pleasurable moment, oh, it feels good, I suggested organize themselves to optimize pleasure. So that, they say, okay, well, let's stay in this configuration because that's going to give more pleasure. And then they developed and adapted and grew to optimize pleasure. And in the paper, I said that's what started the origin of life. These molecules started to organize themselves so they could feel good and avoid feeling bad. Because if you go to any organism and watch its behavior, from single cells to rats in a maze, or dogs, or if you want them to do something, it's all about reward. You give them a sugar cube, or if you don't want them, or you don't want them to do something, you hit them or zap them or shock them. It's all about feelings. Animal behavior, plant behavior, even, it's all about feelings, I think. Why would these organisms organize themselves from simple molecules to more complex molecules and grow and all this and that and develop into creatures and reproduce without feelings? Why would they even bother to reproduce? Why would they do anything other than sit there if there weren't feelings involved? They're fighting against entropy, and they got a lot of barriers. So anyway, I wrote that paper, and then Dante saw it and called me up and said, hey, I want you to work on this project with me. So that's what I'm doing. So we're looking for quantum oscillations in molecules from, they're called polyaromatic rings, from meteorites and asteroids. And if we see the quantum oscillations, then we're going to see if they go away with anesthesia.
And what is the current finding? Like, what is the current knowledge about it?
Two things. In the molecules from Bennu, which we haven't analyzed fully, but we've looked at, there are my cells, very much like the primordial soup, where you have my cell is kind of like the interior. You have aromatic rings in a kind of a fluid with some kind of wrap around it, like a cell membrane. It's not a membrane, but it's something like that. So these are the first cells, and very much like and sometimes these coalesce into. They look like they're trying to make little organ, and these are in the rocks from the asteroid. It looks like life actually pre-evolved. That there was.
How do you collect those samples from asteroids?
Well, Dante Loretta is my collaborator, and he was involved. He was the lead on a NASA project called OSIRIS-REx, which was a 20-year project. It was 7 years in flight, and when it started 24 years ago, he was an assistant to the lead because he was fairly young at the time. And then the lead guy, Mike Drake, they finally got the award, $1 billion from NASA. They identified a particular asteroid, near Earth asteroid, still really far away. They liked for organic, because it was highly likely to have organic molecules. It was very black carbon. They did spectroscopy. They picked out this asteroid, and then 3 years into the project, before it launched, Mike, his boss got ill and passed away, unfortunately. And despite being fairly young, they made Dante the head of it because he had been in it from the ground floor. So he was in charge of this, and it finally blasted off about 9 years ago. And it took 3 or 4 years to get there. And it found the asteroid, and it orbited it for a year. They mapped every inch of the asteroid because they had to figure out where to land. Basically, an asteroid, apparently, it's kind of like a bunch of rocks. It's not really a solid object. So if you landed on it, you go right through and come out the other side. And it's very low gravity. They figured out exactly where they wanted to land, where they had the best chance of getting the carbonaceous organic carbon material. One fateful day, they did it, and it worked perfectly. And they scooped it up, closed the door, sealed it up, turned around, and headed home to Earth after a while, I guess. And so it came back, I guess, in the fall of 23, about a year and a half ago. And since then, all the samples are being, cataloged and looked at and whatnot. They found these what look like cells, my cells, or what nanoglobules they call them, which could be primitive cells. They found big organic polyaromatics. So we hope to be studying that and looking for quantum oscillations pretty soon.
You're planning to do that experiments that work?
Yes. In the meantime, while we were waiting, we did this 6 months a while ago. While we were waiting for his samples, for the Bennu samples, there was a meteorite that came down in 1969 in Australia called the Murchison meteorite because it came down to the town of Murchison. You know, when a meteorite crashes, it spills whatever it's got all over the place. You got to be careful because those molecules could be earthly contaminants. So they always say, anything from a meteorite, it could have been there first. But they found one molecule that got its way into in all the textbooks. And it's completely different than anything anybody's seen on Earth. And basically, it's like a bouquet of these aromatic rings. So you have the hexagons, and you got them like in a branching pattern. And it looks like it could be a bush or bouquet, but then it's squashed down in 2 dimensions. So you see it in 2 dimensions. I was looking at that picture anyway, Dante suggested that we model it in 3 dimensions dynamically, because it's like in protein folding, these aromatic rings attract each other and start oscillating. So that's exactly what we're looking for. So we sent it to Anirban, and his friends modeled it on a supercomputer. And what happens is that the rings fold together and they find the right attraction, and they turn into a dimer, like a peanut-shaped protein, with a part here and a part there, and like a hinge. And then we simulated it dynamically, and it oscillates in petahertz at 10 to the 15th cycles per second, so even faster than terahertz. Some other things, and it looked like it might might have triplets too. We can't say that for sure, and we don't want to say too much because we want to do it again. But something like that could have been the seed for a time crystal or even a microtubule that would develop into life. And so this is some evidence of pre-evolution, that there's already been some development in that molecule before it even got into the asteroid.
Did you publish the paper about this, like the model that you made? Is there somewhere like I can read more about this?
Murchison molecule thing, we just did a poster on it. Because we got to do more simulations because there are a lot of conformations that don't do. We found certain conformations that do oscillate and do make time crystals and actually look like they may try to form microtubules, believe it or not. But it's such a kind of outrageous proposal, even though I kind of suspect it's right. We want more information. That was based on a model of a molecule that came down 50, 60 years ago. And we want to do it on these molecules that just came back from Bennu.
When do you expect like first results of like analyzing this samples that...
I'm not sure. Dante's on sabbatical and won't be back for a few months. In the meantime, we've been working on the time crystal idea because we think time crystal may be actually the secret of life and consciousness, because something that can give you precise timing, instructions, information processing, something like AGI in a molecule and consciousness, and it transcends scale. So it would be good for, something very tiny and it tends to be fast, or something like an elephant that's big and fairly slow. And it had the same information, like in the elephant, from the micro scale to the macro scale, the same information, having like a fractal. I think consciousness may be a fractal, a hologram. Anyway, we're working in the astrobiology area for this. We're looking anesthesia area for what takes away consciousness and signs of triplets. We're looking at the role of microtubules in aging. This is kind of a digression, but Alzheimer's disease is a big problem. And everybody is attacking the amyloid plaques because they're big and ugly and they shouldn't be there, and let's get rid of them. And so they can't come out with a new anti-amyloid drug every year. They don't work. They cost $30,000 per patient per year, and they're toxic. And they keep saying, well, the next one will work, the next one will work.
It's like with traditional cancer treatment.
Well, cancer treatments sometimes work. I don't think any anti-amyloid treatment has worked, because they're barking up the wrong tree. It has very little to do with the amyloid.
How our understanding of Alzheimer's correlates with our understanding of consciousness?
Depends who you ask. I think they're both completely dependent on microtubules. But if you ask anybody else, they go, well, it's the membranes, axons fire. Neurons firing, and the amyloid plaques block synapses. And there's no evidence for either of those that firing causes consciousness, because under anesthesia, axons will still fire if you can stimulate them. And the amyloid plaques are out in the middle of between the synapses. Occasionally they can mess up a synapse, but so what? Meanwhile, all the neurons are rotting from the inside, from the microtubules falling apart. And these people they don't even notice. They don't care, because all they care about is they look at the whole neuron. They look at the outer surface. They're like neurodermatologists. All they care about is the outside.
Neurodermatologists. I love this. Two directions for the conversation. Like, does it mean that potentially the life can originate somewhere else outside of our planet?
I think it means that, there can be life and consciousness elsewhere. And these aromatic rings are everywhere in the universe. They're in the interstellar dust, they're in the atmosphere of planets, they're on other planets, they're on asteroids, they're in they're all over the place, and they're perfect for life. And when I was an undergraduate, I wanted to go to medical school, and everybody said, well, if you want to go to medical school, you better get an A in organic chemistry. And I took it seriously, and I studied hard, and I did. And organic chemistry is all about these aromatic rings, and they're the key thing about life. And they're all over the universe and produced by stars.
You believe that there could be life somewhere else based on your theory?
Yes, there could be life. There's aromatic rings. They're really the essential ingredients for life. I think if they oscillate and get large enough, they'll start tapping into some maybe larger intelligence in the universe. I don't know. I think there could be protoconscious moments here, there, and everywhere, but people say, well, what about something more collective, something more like God? And I don't like to talk about that because, I got enough problems defending what I do believe in. And I learned that from Roger. He would say something, well, I just don't find that useful to discuss.
Judgment-free space here. We're just exploring all different ideas. Then what about God? Like what is, if God exists?
I think it's possible. I think there's collective. There could be a collective intelligence and consciousness, and sense of morals and ethics and platonic values, and probably embedded somewhere in the Planck scale in the space-time geometry. Whether the Planck scale is the lower limit, 10 to the minus 33 centimeters, 10 to the 43 hertz, or there's something beneath it, beyond it. Some people think so. I don't know about that. The Planck scale is small enough, and if we can get it that far, that'd be good enough for me. But something basic to the universe, there could be intelligence, and the universe itself could in some way be conscious. I mean, I don't want to be too dramatic about it, because it doesn't have to be a godlike, single-minded thing, but it could be. Roger also has this theory that the Big Bang was preceded by another eon, and that one was preceded by another eon. And so we talked in one of our papers, we talked about consciousness actually surviving from one eon to the other, and actually maybe mutating and evolving during the transition. And so the universe might even be evolving to optimize consciousness, just like life is evolving to optimize consciousness. I think life quite literally evolved and developed to optimize feelings and consciousness, because that's really all that matters.
Coming back to our conversation about proto-consciousness, so if like this proto-consciousness events happening all around, then can we claim that AI is proto-conscious? Like the current AI systems are proto-conscious.
Yeah, but that'd be kind of trivial, just like my coffee cup's proto-conscious. I don't think AI would translate the proto-conscious in a bit to another bit, because you need entanglement. The primordial soup, maybe very simple, with hours. Or let's just say something simple, like one cell, for example. So one cell might have a billion tubulins, and it's going to have, I did all these numbers, I'm going to just guess now, but it's going to have, maybe 10 conscious moments per second, whereas we have 10 megahertz, 10 to the 7th conscious moments per second, something like that. That means, and it's kind of like photons, so their conscious moments of a single cell will be much, much weaker, and not feel as good, you might say, as ours when we have all this intensity built up. But on the other hand, if you're a single cell organism like a paramecium, maybe 10 a second is pretty good, and you feel good when you feel it. It's better to have some consciousness than no consciousness. So I think these simple organisms probably do. In fact, I think that's what drove life, as I was saying before, that you had to have some kind of motivation to push forward and do things.
With the current development of AI systems, we might see, I don't know, maybe in 10 years from now, or at some point, we might see humanoid robot, that look like human, acts like human, expresses its feelings, says it has pain. Like if you remember Westworld TV show, let's say that kind of robot is based on GPUs. We don't have quantum computing on practical level. Wouldn't you believe that creature that you're interacting with is conscious, at least from your perception? And it doesn't matter if it's conscious or not, but the way it interacts with you in a physical world, it looks like human. And your mind creates that illusion that it is conscious.
You're asking the wrong guy, because I'm biased against the idea that it could be conscious. It's even harder to define consciousness, and I often say that the best definition of consciousness is what goes away with anesthesia and comes back when the patient wakes up. And I borrowed that from John Searle, who said it's what goes away when you go to sleep in a dreamless sleep and wake up in the morning. Whatever goes away with consciousness. I don't think you can anesthetize a computer. Now, could it happen in some other way? Yeah, it could, but I think it needs the objective reduction collapse, and I don't know how you could do that in silicon, because it doesn't have the ring. So it'd be very, very difficult. It's possible. Now, on the other hand, well, let me say two things about that. I gave a talk about this recently, and I said basically I talked about deep learning as more layers than the other layers. I didn't go into the other stuff you just did. And I said, if AI was really cool and wanted to do consciousness, they would have to do not just deep learning, but fractal deep learning. And because that's what the brain does. And so I had a slide of this. Actually, I can send you the slide. It's like, instead of putting more layers in between, you take each node that you do have and blow that up and put a whole network inside that. And then you take every node in that one, blow that up, and put a whole network with that. Because that's what the brain does. Because inside each neuron, so the brain's a network of neurons. You go inside one neuron, you look inside, you see these microtubules. It's a network of microtubules. And then in the microtubules, you have oscillations in kilohertz, megahertz, gigahertz, terahertz, the smaller and smaller components of the microtubules, faster and faster. So the microtubules will be processing at all these different levels. that are the same as higher levels. So it's like a fractal. And at some point, you're going to cross the objective reduction and have consciousness. My AI colleagues have said, if you want a conscious AI, make a fractal deep learning. Whether that's possible or not, I don't know. However, I think I mentioned this earlier, but my friend Anirban is building an organic, warm temperature, self-organizing quantum computer in India. And it's basically, he starts with what he calls brain jelly. When he first told me about this, I kind of like, oh my God, he's really gone crazy now. The thing about Anirban is eventually you realize he was right from the start. I think he's right about this. So probably 15 years ago, he made this polymer that self-organizes and grows. And basically what it's doing is it's optimizing a helical oscillator. And so he has these organic rings on a helix, and they self-organize, and the rings line up, and then they oscillate. So you get it's very much like a biological, very much like a microtubule, actually. It's the essential ingredient. And also, DNA is a helical oscillator too with organic rings. So you get enough of these helical oscillators, you can interact with them with optical photons or microwaves, or both, I forget which. And so you can interact, and he's building one with, I think, 1,000 qubits. Is that right? And it'll be warm temperature. And basically, compared to, cold temperature quantum computers, it's really cheap. It's inexpensive. So they just got they actually started building it, and they just got a big grant to go for the final for 25 million from the Indian government. Now, in quantum computing, that's probably not a lot of money, but for India, it's a lot of money. But they think that they can leapfrog over the cold technology, the cold quantum AI technology. If I had to bet what type of system, quantum system, or any system would be conscious, I'd bet on an organic warm temperature quantum computer based on brain jelly, as funny as that sounds.
This never happens. We'll stay like in a research stage. Then basically AI, even if it's part of our daily life, it's it looks like human, you still won't believe that it has some consciousness, or it should, or at least it should be treated as a sentient being.
Everybody likes this word sentient. I don't know what it means other than consciousness. It's like another word for consciousness. It's like, let's call it something else so people won't care. Sentient means awareness, awareness, experience, any feeling of any kind. I think it's all part of consciousness. So giving it another name doesn't help. People have tried that, and I kind of push back against that, because they're just changing the subject, but not really changing the subject.
Like basically what people say, like AI is just like a tool. It's like a hammer, and we should treat it as a hammer. If hammer looks like human and like interacts with me, and through that interaction I naturally develop emotions, and like people already reporting that they have feelings to AI. And to be honest, when I use AI system for my work, and if it gives me like really great answer, it really helps me, I do feel the spark of emotion, that warmth to that, oh my God, it helped me. And like really,
but wait, those are your feelings.
like,
They're not
when I
the
use
AI's
hammer, I don't
feelings.
have emotions. I don't care. My point is, like, should we even in that case treat AI as a tool and like treat as a slave, or we should at least have some respect and some consideration to it?
I have consideration for my refrigerator, and for my computer, and for my iPhone, and for my car.
Okay, should you treat it as your dog? I guess like your consideration to your dog or to your cat is different than your consideration to your microwave.
True.
You treat like
They're alive. They're conscious. I'm going to be respectful no matter what. And we had AI systems came in anesthesia during my. And at first, I did anesthesia a long time. And at first, we wrote everything down. And then they came in with these machines that would record everything. And most of my colleagues said, "Oh, hell, we don't want that. We don't want anybody to know what really goes on in here, because blah, blah, blah." I said, well, it's going to catch everything. So if you're worried about something, common occurrences, they're going to show up. It's actually protected. To make a long story short, AI became very, very useful in anesthesia, and it's very, very useful in everything, a lot of other things. So I'm not against it. I just am, because I'm heavily invested in the theory of consciousness, and resent people assuming that an AI will be conscious because it's a computer, because consciousness must be computation. I don't think that's right. I think consciousness is more like music, and particularly music embedded in the fundamental level of the universe, space-time geometry, which was Roger's idea, which can get you into spiritual implications if you want. I just object to the idea that AI will be conscious or is conscious, or that there's nothing special about consciousness, because I think there is. And I think people are fooling themselves to say that, to sell more this or make more money or whatever. I don't know. AI is great for our society, for me personally, and everybody. It's just not conscious, and I don't think it will be.
Do you think that if you were falling in space, that you would slow down after a while or go faster and faster? Faster